This is the Vernier anemometer. It's used to measure wind speed, so you might use it in weather studies, in investigating how fast the wind's blowing. I might use it here to look at the wind speed produced by a variable speed fan. It may be used with, say, the Kidwind project, where you're designing different kinds of windmills and using it in conjunction with, say, a current sensor or a voltage probe to measure the output of a windmill. So it's very useful in that range. The way it works is that you have the impeller here, and as it turns, it actually turns a magnet, and it induces a current in a coil, and so it produces a voltage that the device can read. And so the faster it spins, the higher the voltage, and you get your wind speed reading here. We suggest that you want to use it with wind speeds in the range of 0.5 meters per second up to about 30 meters per second. If it's too slow, the value may not be correct, or if it's higher than that, it's obviously you're going too fast there. This threaded hole here allows me to attach a threaded rod, and so I might use this so I could mount it to, maybe with a clamp, if I wanted to actually mount it to something. If I just wanted to use it outside, I might just remove this and just be able to hold the sensor on without it. So that's just a standard thread like that you might have on a tripod if you wanted to. So let's collect a little data with this. So I need to plug it into my LabQuest, and it's an analog sensor. So it's going to go into one of the analog ports here. So I'm going to plug it in. And so now we've got reading there of 0. It's just laying on the table. Let's take a look at our default collection parameters. So it's a time-based. It's going to measure the wind speed as a function of time, 10 samples per second, and then the duration of 60 seconds. So it's just going to be a 1-minute collection here. Maybe I could test and see if it's working. I might go. So as I turn that, we obviously now get a reading, so it's turning, and I'm getting the reading here. I am going to hold it up in front of the fan, and what I will do is I'll start collection. I'm going to hold it up here, and then I'll turn the fan on, and so I'm creating the wind, and we can measure that. Begin collection. I press the collect button there, and now I will hold it up here, and I'm going to turn the fan on. And so we start to measure the wind speed there, and then turn it up a little higher. There we go. Let it level off there a little bit maybe. Now go all the way to full speed. So we'll just kind of let it level off. And now let's turn the fan off. Just keep holding it there in front of the fan so we watch it, the speed decrease. So at this point, I'll just go ahead and hit stop, and we can stop our data collection. So now we have some data to analyze. So we see that as we turn on the fan, the wind velocity began to increase there, and then finally we got it to where it leveled off there, and then when we turned it off, the wind speed decreased. We might be interested in knowing something about, what was the maximum wind speed generated by our fan, so we could use some of the analysis features like the statistics function. So I can go to the statistics tab there, and then up here we see the maximum wind speed was 5.3 meters per second at 27.8 seconds. Again, this is the anemometer, so for measurements of wind speed, it's the device you would need to use. It's easy to use for all different age ranges, so elementary through college could use this, and so for weather studies, alternative energy studies with windmills, it's a great sensor to be able to use.